Hey everyone, welcome back. Have you always been wondering about data archiving, unarchiving, compression and decompression? What's the difference and how one can efficiently perform these actions in Linux? What are the available tools and which one is better? Well, in today's video we are diving deep into one of the most crucial aspects of managing data in Linux, which is archiving and file compression. At the end of this video, we will do a comparison between those tools in terms of performance and efficiency, so please stick to the end. Archiving refers to combining multiple files and directories into a single file for easier management, transfer, or storage. In Linux, common archiving tools include tar and cpio, which is often used with the find command, as well as r and pigz, among others. The most commonly used tool is tar, shortly for type archive. We will deep dive into how tar works and most of its features later on. Compression, on the other hand, is the process of reducing data size by encoding it more efficiently to save storage space or accelerate file transfers. Let's start with the tar command, which is an archiving tool that allows you to group a set of files and directories into a single archive file. For instance, here we have two directories, data1 and data2. In data1, let's see what we have. We have two text files. So in order to archive this directory, we would need a similar command to the following. So here, after the tar command, we specify the flags. So here the C is for create, the V is for verbosity, and F specifies the archive file name. Then comes the name of the archive, which generally ends with the tar, and then whatever comes next is what we want to put in the archive. In our case, we want to archive the first directories. So here, since we specified the verbosity, we would see an output like the following, like the directory that's being archived and the files as well. Another useful option that we can use in tar is the exclude option, which allows us to exclude directories and files that we do not want to include in the archive. So let's say that we want to archive everything in this data directory except whatever ends in this temp file, in this temp directory. So we would need a similar command to this. And then we put the archive name. I'm gonna name it data2.tar, and then here we use the exclude like the following, and mention that whatever in this temp directories we don't want to include in the tar. And then comes like the directory or the data that we want to archive. So a command would look like this. Then if we run this, we see that we are only archiving data directory and those two text files. So as you can see here, we did not include the temp directories in the archive. And here we can double check that we did not include anything from the temp directory using the T option, which is used to list the content of an archive. So TF and then data02. So as you can see here, this new tar file that we have created, there is no content of the temp file that we have excluded here. Okay, let me clear this. Okay, so remember so far we have been only doing archiving. So there is no data compression, and here if we check the disk usage of the directory that we have been archiving, we see that, okay, let's let's make it a human readable, so it's 21 megabytes. And also if we check the archive size, it would be with similar size, like it's 21 megabytes, since here we are not doing any compression, just archiving. If we want to compress the data alongside the archive, we would need to add like additional flags to tar. For example, like the most used flag is the Z flag, which tells tar to use the Gzip in order to compress the archive file. So let's go back to the archive command. So something like this, zvf, and then we include the Z. So this will tell tar to archive and compress, and then we put the archive file. So it's gonna be data and then dot tar and then dot gz. Here it's just a naming convention, but it's like useful to make others aware that we have been that we have compressed this file. And then we just put the directory name that we want to archive, like this. So now if we check again the size of the generated archive, we would see that this is the original size, like the original archive size, which is 20 megabytes. But when we do the compression, the data compression, it becomes only 21 kilobytes. That's really great improvement. Okay, now let me clear this. So I'm gonna clear all of those archives that we have created, and I'm gonna show you something that's really cool. So let's assume that you have a large amount of data or a large amount of files, and then even when compressing them, it's still large, but you need to still transfer this somewhere. Well, you can combine the tar with the split command in order to produce smaller chunks. For instance, here in directory 2, we have, let's check its size, which is 136 megabytes, and let's say let's say that we want to compress it and then split it into smaller chunks of 10 megabytes for each. For that, we would need a similar command like this. We tell tar to compress, and then give it our target directory that we want to compress, and then we pipe the output to the split command like this. And then here in the split, we specify how much the size of the chunk we want it to be. Let's say we want it to be 10 megabytes each, and then we just specify the prefix of the chunks. For instance, here data archive, and then something like this. Let's see what's gonna happen. So as you can see here, we are seeing the verbosity that's printing us what are the files that being compressed and archived. Okay, now it's finished, and then and here if we see what we got, we see that we have I'm not sure how many chunks, but let's check their sizes. So here we have chunks with 10 megabytes each. If we want to count them, we simply use this command and then pipe it to W c-l, and here we just specify the prefix of the files that we want to count, and then use this wildcard here. So we have 12 files, and each file is with 10 megabytes, and the rest is like 3 megabytes, which are like stored in the last chunk. So this is very useful. So now you can just like send them one by one over like the internet or somewhere else. But it becomes really easy if you have like a large file or a large archive that you want to split it into smaller chunks. Now, if we want to extract files from those chunks again, what we need to do is the following. So I'm gonna start by creating a temp directory that we will put all of those chunks inside. So let's make it temp, and then let me move everything with this prefix to the temp directory that we have created. And then here we have all the chunks. Let's say I want to extract them here. So in order to do so, we would need a command like this, which is like the cat command, which we will pipe to the tar. So here we put cat, and then we specify the prefix and use the wildcard to select all of those files, and then I'm gonna pipe the output to the tar. And then we say to the tar that we want to extract, and then enable the verbosity. And then we need to mention also that this is like a compressed data. That's why we need the Z flag. And then, yeah, that's it. So you see here, we did not mention the F, since there is no file. We are just getting the output from the pipe. So here we get the verbosity, and then if we check what we have here, we would see that we restored back our directory. If we check its size, we would see like that it has retained its size. So we did not lose anything. However, Gzip is not the only compression tool. We have bzip2, xz, which are also widely used. We have also Lzma and Zstd, which are becoming increasingly popular. So back to our examples, let's try those out. So I'm gonna first generate a tar archive from data directory 2 without applying any compression. So I'm just going to ignore the verbosity, and then mention the data dir 2. So here we see that the data tar has like 136 megabytes. For instance, here Gzip can be used like following, and it's gonna perform a compression of this archive file. It's taking some time since the archive is like not small, and let's see what we gain it here. So here we see that we have dropped from 136 megabyte to 114 megabytes. Okay, now I'm gonna decompress this archive again using, now we would need to use like this Gzip or G and zip, and then this would restore back our archive. Okay, now let's move to other compression tools. We have this bzip2. It's still 114 megabytes, so it's not so far from the Gzip. Okay, I'm gonna decompress it again using this flag. And then we have the xz. Okay, let's see. It's still 114, no improvement so far. But I assume since this is like this data is like images, then which already has been compressed, so not much to do there. But yeah, nevertheless. Okay, we have also this. Let's decompress it using the D option. Next we have the Lzma. Okay, let's check out the output. Still the same. Let's now decompress using always the D option. And last but not least, we have the Zstd. Okay, that was pretty fast. And it generated like a slightly larger file, but it's still like very fast, very fast. I assume to decompress we can use always the T option. Also decompression is very fast. Okay, let me clear this. And now we have two more compression tools that we are going to cover in this video, which are the pigz. So this is like basically the Gzip but parallel. So it's similar to the Gzip command. Just run it as the following, and you see how fast it was. I assume like the compression ratio is like the same. It's 114, but like it was pretty fast using this multi-cores. Let's see the decompression. It was also like so fast. Okay, and apart from that, we have also like the pbzip2, which is essentially a parallel version of bzip2, and it can be used like following. Let's see. Okay, I think the first one was faster, but still like this also like much faster than the original bzip2, and the compression ratio is the same, I think. Okay, it's the same. And we have also just decompress it and see the performance. Yeah, it worked out pretty fast. Okay, before moving any further in this video, I would like to highlight that the tar command or the tar tool allows you to select the compression algorithm that you wish to use. Let's check the tar manual and look for Gzip, and we see here that in order to use like a different compression tool, we just need to update or change the compression flag or the compression option. Here the Z is like for Gzip or G and zip in order to decompress. The big Z is for the compress algorithm. We see here that we have the Zstd option. Also we can use like the Lzma or Lzop, Lzip, and minus pigz for the xz algorithm, minus G for the bzip2, etc. So here we can use the tar command in order to archive and compress using one of those available compression tools. For instance, here, let's say, let me remove those tar files. So if I want to compress using the bzip2, I would need something like this, tar cv, and then instead of putting Z for gzip, I use the G option, which is for bzip2, and then specify that I need it in, let's say 03 tar.bz2, and then mention this directory that we want to compress or archive. Yes. So this basically this command like did perform an archiving of this directory, and then it compresses the resulting archive using the bzip2 tool. And if I wanted to use the Zstd with the tar command, then I just need to specify that in the option. So here CVF, and then I put the name of the archive, data.tar.zstd, and then specify the Zstd compression tool, and then just the directory that we need to compress and archive. Now let's run a comparison in terms of speed and compression ratio between all of those tools. So for that we would need to automate this like through a bash script. For instance, we have here I've created this bash script to automate things. So first we take the input file, which is an archive file. Then we print its size, the original size, in kilobytes. Afterwards, we loop over all of those compression algorithms or compression tools. Then we populate that we are doing testing for this tool. And then we start by calculating the duration that it takes this tool to do like the compression. So here like we run a different command for the Zstd in order to remove the original file, so we just need to add this rm flag. Yeah, and then here when the compression is finished, then we print the time that it took, and then we calculate the compression ratio. So we deduce the file size of the compressed file. Then we put that in a Python command in order to calculate like the compression ratio. Actually, we need this in order to produce like a float ratio, because like in Bash we don't support floating point, we have just like integers. So that's why we needed to do this in Python. And then we print the compressed size and the compression ratio, and we do like the same for the compression. So we calculate the decompression time and print it here. And in the end, we do like some cleanups and remove like the compression file and the temp file. Yeah, this is basically the bash script, what it does. So let's try to run it out. In summary, the comparison of compression tools highlights varied results that reflect the default settings of each tool. It's important here to note that each tool offers customizable options that can influence both the compression ratio and the processing time. Thus, while these default results provide a general overview, optimizing individual settings can achieve different levels of efficiency and performance.